Cool. Okay, so let's get started. So welcome everyone. Thanks for joining on Friday morning. Today we have Saquib, who's a longtime friend of mine and also one of the organizers of our Dynamic Abstractions group. So Saquib is a technical founder building infrastructure for human-agent interaction, which he will talk about today. And he's currently leading Oak Network on a 16Z-backed spinout from Kickstarter, which is supporting enterprise clients across multiple regions right now. Before that, he also founded multiple companies in several areas of deep tech, architecting Web3 protocols and IoT hardware to building interactive AI and scientific visualization tools at places like MIT Media Lab and Adobe Research. He studied at MIT. That's where he got his PhD. And he studied HCI and Embodied Cognition there. And his current academic interests center around how human agent systems can accelerate scientific, engineering, and educational workflows. And outside of his work, he's also a magician and graphic novelist. So he's also a very creative person. So really excited for today's topic and discussion. So Saquib, take it away.
Thanks, Sang-Ho. Well, that was very kind. Thank you so much. Okay, so I thought maybe instead of like a full-blown presentation, I'm just going to try to show you some stuff that we have been building. This really started, and then this is actually collaboration that started probably during my PhD days, and it's been a little time after that, and I have been building in this space for embodied mathematics for quite some time, and the collaboration with Rubaiyat, who is here, for example, and then exchanged a lot of notes with Sang-Ho and a lot of the other members in this particular community. So it's been a blast just trying to get feedback as I build stuff from this community. So I think I'm going to do some of that today too. So I will I'll try to kind of breeze through the presentation quickly. It's a bunch of text. I'll show you, some of the things that we have been developing within Visual Studio Code, and then I'll open it up to the discussion. And yes, as Sang-Ho said, thanks for joining on a Friday morning. So yeah, let's get started. And feel free to stop me anytime you guys have any question. So I have been kind of working on embodied mathematics for some time, and there are many definitions of embodied mathematics. If I were to try to put it in one sentence, it is the opposite of the way we do mathematics right now, which is a lot more symbolic. Let's call it symbolic mathematics. And embodied mathematics is generally about using embodied interactions in math. Now, what is an ideal world where embodied mathematics can shine? So what we want, and really what this community has been thinking a lot about, is dynamic abstraction. So really what we want is seamless transitions between symbolic and embodied and visual mathematics, right? Like that is the ideal utopic world where we want to get to. Of course, agents are the new hot thing, and I do think there is a lot of potential when doing embodied mathematics. In fact, it unlocks some things that we could not do previously with custom designed interfaces. It actually provides a lot more flexibility at this point. So how can we move towards agent-assisted science, math, and engineering? And tools for thinking, that's something we talk about a lot in this community, right? And I would love to just focus a little more on mathematical thinking today. And and at the core, it probably, the ideal world probably looks something like this, where we are able to define some building blocks or elements for whatever, like we're defining a math problem. We are modeling some simulation, we are solving an engineering problem or whatever, right? We should be able to define some building blocks in a fluid medium. Now, all of these are, of course, like vague terms, but I'll try to make it a little more concrete. So, and then once these things are defined, we should be able to think with an agent together and scale from that thought and hypothesis to actual code and other generative artifacts, right? So really like being able to say that, hey, unify the sequence from whiteboard. We start prototyping a problem on a whiteboard, and then on the other side, we have the production grade software and tools that comes out of that. Like maybe I'm building a feature, an algorithm for a particular task in a software. So I'll start from the whiteboard. It gets to define my mental model, and then I'll get to the code part. I'll probably draw some architectural diagrams. So there is a sequence of events that usually happens. And what we're saying is that, hey, can we have like the holy grail of a lot of what we probably talk about or want in the world is, oh, can we unify the sequence? Can we have one single workflow where all of these things happen? And it is almost non-existent, or like it's a myth basically, right? Oh, can we make it happen? So that is the ideal world. And of course, like when we are thinking with an agent together, there are other challenges that are introduced, which is, oh, agents will hallucinate. They are not probably consistent with their outputs. You have to verify the output that they're producing. Whatever elements or building blocks that you defined in whatever form, like if I call it the fluid medium, then you have defined some building blocks in that fluid medium. So how do you map elements to actual processes that can be coded up, basically, right? So there are all these challenges in the ideal world. What would be ideal examples? Like, what is our dream world where we are trying to get to? This is like, and I'm going to just probably put some moonshots out there. So one would be, hey, turn every math and science textbook into, if you're familiar with Veritasium YouTube channel, or like 3 Blue 1 Brown YouTube channel, where they take a math or science concept and you see a lot of animations, you see a lot of interactive tools that they develop to describe the particular mathematical concept. That would be the ideal goal, like like one of the ideal goals, right? Like, oh, take a textbook, turn it into a Veritasium video. A lot of things like to figure out over there, but let's just at a 50,000 feet level. That's our ideal example. An engineer who's actually working like working in an industry, let's say a mechanical engineer designing a particular, let's say he's designing a webcam or she's designing a webcam. There are a lot of different pieces that go in there. It's the PCB that you're designing. You are designing the form factor. You're designing the 3D model. You have the code that goes into the firmware. A lot of things come together, and there are like hundreds of different workflows that you can think of, right? Different software tools and workflows an engineer uses every day. So again, ideal goal, or like the dream goal is, hey, can we have one unified workflow for these folks, right? And how do we start getting to that sort of paradigm? So now, the way to do that, of course, we are not going to rebuild. Maybe like we're not going to rebuild AutoCAD, or like or let's say Blender, or like whatever software that we can think of. We're not doing that. However, I think agents unlock a lot of new features and abilities for us. One example being, let's say, Claude browser agent. Like you want to get something done, you give it some sort of prompt. It tries to get it done on the browser. So in the same manner, like can we imagine that, oh, like I have Blender, I have COMSOL, I have AutoCAD, like I have all these different tools, I have video editing software, so many things, right? So doesn't mean like we're not saying that math, science, computation software tools need to get replaced. But what we're saying is that, oh, can we work in unison so that it feels like I am actually under one workflow, although there are many tools that are getting executed in the background, right? So with the help of agents. So that's one ideal example or outcome. Now, of course, like natural language-based science and engineering workflows. So I know, like, I've chatted with Rubaiyat for a long time about this stuff, and and a lot of the other folks in this community about how do we get to an AI assistant for scientists, basically, right? And Rubaiyat, I, and Sangho and Yan actually did another talk, like at some point, like I think 2024, where we were talking about Feynman using an AI assistant and all that. Right? That was a fun talk, by the way. But so it's sort of similar, that what a scientist is saying, taking that, like from a natural language perspective, taking that, constraining it enough so that we have some bounds to what the AI agents will generate, but still remaining in the generative realm, so that we don't have to design custom rules and solutions. Rather, we let the generativeness take over, right? So how do we get there? That's also like another holy grail that I have been thinking about, and our community in general probably, like, and it doesn't have to be mathematical. I think at large, we've been thinking about some of these problems generally. So, okay, so, and then side note that the results that we get from interacting with the AI agents, they should still be callable. And because the outputs are usually text, like the agent is sending you text, basically, right? So how do we map it back to the workflow that we are working with? So it should be callable, interactable, and usable directly in code, or like in other kinds of cells, like, and it's obvious, like I'm working in a notebook environment right now, so I'm just using the word cells, basically, right? So, but where is the world right now? The world is, I think it's and I have been building products for some time. I've been building startups, and there are, whether you call it a reckoning or like whatever you want to call it, it's there is a gap between, or not even a gap. It's more like different use cases or different audience for research and products, basically, right? Products that get used and that get sold, and someone is willing to pay $5 at the end of the month for that product because it solves a problem for them, basically, right? So taking it from that research prototype to that particular finish line, I think there is some gap that exists. So, and the main gap is not that, I think, we tend to create a lot of highly creative interfaces, like when we are publishing in Whist and Kai and all these places. And these are great tools, and it's the reason they're not scaling. It's not that they aren't useful. They are super useful, and like, I mean, these are very powerful ideas researchers are coming up with. But there is usually a massive inertia among users to adopt new tools and new modes of thinking. Right, and there is no shortage of new tools and new prototypes and new modes of thinking that we are talking about. So, whenever I'm kind of when I look at it at this point in my life, when I look at the research community and the startup community, the industry, and like getting a product from a prototype to like having people pay for that product and all that, right? I do think that the solution is somewhere in the middle. So we have to meet the users in the middle. We have to build tools for them with which they're already familiar, and we have to push or bring changes incrementally, basically, right? And solve some pain points for them right away, for which they're willing to pay for that product. And it's important because if I just take a detour, just a short detour of, like how funding works in academia, how funding works in industry research, and how funding works in companies, all of these point towards building something tangible right away that's useful. And otherwise, like we will keep producing prototypes and we'll never get to products. and it's not being useful. I feel like, oh, in the last 15 years, we have seen a lot of different kinds of prototypes, but we can probably say that, oh, like a lot of the different visions that we have seen in the research community, we can probably say that, oh, they have really translated well to the end users, basically, right? Like, I mean, I think that's a very strong statement. So I don't want to kind of course, say that, oh, the HCI community doesn't have a lot of contribution. Of course, we do, and contributions show up as different features in different products. But why I started this project, and I'm calling it Noyon, the reason the project started is that, oh, like, it's usually in the mix, in the chaos of the real world, where we get lost in, like, okay, where is research funding coming from? Where is the product funding coming from? Because of some of those bureaucracy, like, we get lost in the research gets lost, or like the end result that shows up in the product is not really the original vision the researcher had, basically, right? So that's what I'm trying to kind of do over here, that some of the experience that I've gained building startups, can I start some sort of initiative, or like a company of some sort, which is, and that's another thing, like, okay, are we doing research, or are we a for-profit company? So to be honest, I don't know yet, but I mean, I'll say a little bit of both. I mean, publishing research papers would be definitely nice and great, but the main goal is to create and maintain a product that people can start using today, right? So I intend that, like, most of the works will be open sourced and owned by the community, and I intend to make it a public benefit corporation. What that means is that it can earn and have profits, but it's going to be a non-stock company, right? So there is I can get into the details of that, like why stock-based company derails you from the vision in certain cases, basically, right? Like, because you're really following the shareholder interest and all that, right? So there is that. But I won't get into that. But so that is the project right now, and that is the ideal work. But what do we have today? So the Noyon team, like, which is a small team, very small team at this point, we have been trying to settle down with some middle grounds. Okay, like, there is a lot of good research done in the HCI community. How do we take that research and turn it into a product that, like, as a researcher, I would know that, okay, probably I did justice to some of the other researchers with their ideas, basically, right? Like, at the same time, I would love to be able to say that, oh, like, it's a product that people will pay for, or like, it will find some immediate use cases, right? So that's sort of like, okay, so what kind of input modalities are we talking about? Of course, there are a lot of different input modalities, but we kind of kept it simple, which is like pen input, text input, mouse, etc. Where does an interface like this, where we're talking about having a unified workflow for engineers, mathematicians, educators, and all these folks, a lot of the times they will be probably on some sort of IDE. So we chose to go with, like, Visual Studio Code and Jupyter Notebooks, and bringing or adding changes on top of those things, basically, right? So getting, which is familiar to most users, and getting to a lot of users right away. That would be the hope. Tool calling for agents, like, we are going to show Blender as an example, because it has its SDK and Blender kernel. All of these things are open source, so it's much easier to work with, as opposed to like, when we are working with commercial software, there can be guardrails that we don't want to deal with right away. So today, like, some of the examples that I will show are will be based on Blender as an extended tool call example. So what we are building is essentially a client IDE, which is like, right now it is a Visual Studio Code extension, and you're seeing it over here. So I mean, it looks exactly like a Jupyter Notebook as you open up in a Visual Studio Code with some other functionalities, and I'll get to that in a little bit. So one other thing that we're building, and I think it's a very crucial thing, is a visual grammar constructor agent. So let's say if I give it a text, when I say that, hey, like, let's take a textbook, or if I if a scientist is providing some natural language instruction to an assistant, let's say the instruction is a higher temperature makes molecules move more rapidly, right? We want it to get translated into a set of primitives and mathematical relationships. And from those artifacts, can we use dynamic code generation, which is kind of all the rage right now with coding agents, basically, right? To create interactable animations, just one example, and then other sorts of artifacts. Now, what are the constraints that we need to put in for this, right? So this is active work. Like I wouldn't claim that we made a lot of progress over here, but this is our this is sort of our way to like when I see a lot of Kai papers or like Wiz papers, I'm up to date with all of these papers, and I see that okay, what is our process? We usually do like a design study to understand a particular domain, and then from that design study, we are saying, hey, this seems like there are 5 different elements that we can use. Probably there are 3 different interactions that we can come up with for these 5 different elements. So we go like, these are very handcrafted, which is why they're great. Handcrafted stuff is great. And I'm not sure if AI agents can get to that level of, like, like, or maybe not, like, we'll see. Like, I mean, maybe it can do a better job. It depends on the domain. But the point is that, can we use generative agents to generalize this process as opposed to going just like the way we do research, which is like paper after paper, we take a domain and then we study that and then we come up with handcrafted rules. And so that's one question, right? Like, and to what extent can we rely on the outputs at that point? So this is like a very open-ended problem, and we don't have a solution for you today, unfortunately, but I'm hoping that you guys probably will have some ideas, or like, I mean, maybe things you're already working on where we can take inspirations from. So the other thing that we're building, as I said, is extended tool calling pipeline. A lot of the agent development kit that you find, let's say from Google or Claude and all these things, you'll see that there is a certain pattern where you will have to define the tools from beforehand, right? Like you'll have to write the code from beforehand. So if we want to utilize other software as your tools, so like we have to extend the pre-programmed agent tools to dynamic tools using code generation on the fly. And in fact, you'll see like if you use Anthropic coding agents, you'll see that it does use like dynamic code generation to come up with tools on the fly, basically, right? So we are taking inspiration from that sort of paradigm, and we are saying that, can we utilize and that opens up other software as your tools as opposed to pre-programming tools that are only that's what the agent development kits allow you right now. So we are doing work to extend that for mathematical computing. And then, of course, an agent server, a collection of agents that help with the dynamic code generation, right? So I'll show you some demo notebooks. And as I said, unfortunately, we hit red limit right before the talk. So I'll show you some of the notebooks, and also I will also tell you that, like, probably you can't see, but I'll show using my camera that I actually have a pen input, like a tablet over here. And I have been working with my pen to actually doing, like, I mean, drawing the strokes, and, like, basically I'm using my pen or stylus in Visual Studio Code to do these things, right? So, okay, let's take a look at some of the cells or some of the demos, basically. I'll by the way, like, I'll stop there a little bit before I go into demos. Like, any immediate questions before we go into the demos? Yeah, Rubaiyat has.
Yeah, Saquib, just to give us a little bit more context, previously, in HCI, there was a clear role, like the users or creators and the designers of the softwares. And then there's this, like, the medium, like it could be CAD or it could be custom-made software. Now the boundaries are blurring between creators and designers because, creative experts can build their own tools. using these powerful tools, and softwares are becoming more malleable. But it's for experts, right? I mean, people who know the domain well, have years of experience, know how to think about tools. In the past, you have worked on, embodied mathematics, which is more like novices and amateurs who don't know how to think yet, or how to think about tools, how to build their own tools. I'm just curious, when you are doing this work, what are you specifically thinking about? Experts building their own tools, or are you thinking about designers creating something for novices, for instance?
It's a very good question. I think, of course, the naive answer would be, all of them, basically, right? But I would love to say that if I could, basically. But in reality, yes, you have to define your user pool, at least the initial user pools who would want to use this. I would say I'm focusing more on experts right now. In fact, some of our collaborators, like we have collaborators in mechanical engineering, in cosmology and astronomy, right? Like, so as we're building some of these tools, we are having them use these and taking feedback from them and all that, right? So right now it is a little more expert focused, and I also think that it can become an educational tool. Like, however, probably we're just starting out with experts. And if you ask me why, I don't have a good justification yet. I probably it's just my frustration that the expert software, like there is a lot of work done on the educational side. Like we see a lot of prototypes, and a lot of the things that we build end up finding their use cases in education because it's more explanatory. But from an explorable perspective, I feel like there is less work done. This is just my personal view, basically, right? So I feel like there is less work done, and experts are still using like things that they coded up in Fortran, like in 1980, or or something like that, basically, right? So I think there is a lot of work to be done over here, and just even from thinking from a business or product perspective, I feel like, that is something that probably that's probably less touched, I would say, right now. That's my guess. We'll see.
I have a follow-up question talking about experts. So, again, similar context, now experts can make their own tools, and, some business models are probably shifting, instead of providing tools, giving them substrate, like, for instance, powerful world models, right? People can, fine-tune to their own needs, and, build tools on top of those world models, for instance. I'm just curious, what would a business model in this world would look like for experts? Do you have any thoughts on it?
Yeah, to be honest, I haven't thought that far, to be honest. But my general hunch should be experts should be able to use familiar interfaces, because I still feel that agents are such disruption that everyone is scrambling to find out, okay, what is my mental model? What is my workflow, basically, right? Even as software engineers, or as coders, or as prototypers, like all of us are probably scrambling to figure out what workflow works best for us. And I feel that some scaffolding is still needed. And as you use some of these agents to develop the artifacts that you want to develop, right? And hopefully the scaffolding is something like this, the Neon interface, where you're still in Visual Studio Code, like or your Jupyter Notebook, things that you're familiar with, but then you are you are taking advantage of the agents, and you're getting back some of the artifacts produced by the agents, and you're able to tell the agents what kind of artifacts you want, basically, right? So probably in that way, Neon is probably just middleware, or like just a scaffolding layer between the AI agents and the experts' usual tooling.
Thank you.
Cool. So I'll show some, like first thing you'll notice is like, you can add code cells and markdown cells, just like you can add like in Jupyter. But you're going to see that there is an AI cell, a drawing cell, and a CAD cell that we added over here, right? So I'll start with the CAD example because we have been working with the mechanical engineering lab, and like then generally it's interesting to have CAD in Visual Studio Code. So like I wanted to kind of show this example and how we are utilizing Blender as sort of like the external tool to get our work done, essentially, right? So so this is the model that you're seeing over here. I'll just I already actually started Blender via, like when I said like open Blender. So from this session there is so this Blender session is running, so I can make changes in this model. So you'll see that there is like an add-on that we created for Blender. It's called Neon over here. And like we can make changes to the mesh. We can create new mesh. Let's say change the shedding, subdivide the mesh, repair the mesh, or do any sort of deformation, anything that you want. You can do it manually over here. You can also tell the AI agent, which doesn't work very well right now, by the way. Like, I mean, we have been experimenting a lot on that node, but the reason I'm not showing it in the demo, we're not satisfied with the results yet. But we're trying to kind of get that done. But the idea would be that, oh, like you make your changes in the mesh, and like you could just come here and you could load the model directly in here, basically, right? So I also want to point out that there is like a lasso tool that you could use, and that's where, you know, like the pen input comes in. So something that happens a lot, let's say I want to do a heat simulation on top of this 3D model, right? Let's say you are a aeroplane designer, you're trying to simulate the heat on a particular wing or whatever, basically, right? So I should be able to use my pen and select some. Hold on, I hope this is working. Oh. Okay. I probably need to. Okay. Some problem in the server maybe, but take my word when I say it, that I am able to, you know, like select regions or, you know, like draw lassos on top of the model and define values for them, basically, right? So when I do that, like, and I've actually done that previously, like, I mean, I selected this part, like the eye of the monkey, and, you know, like define particular values. I took these particular areas and I defined values for them. And now with that, I am able to see a particular heat simulation, basically, right? So what I do, and by the way, so I labeled it. So I labeled this 3D model as ball, basically. And then I am able to actually just say in the code, I can directly reference it, right? So when I say print ball, it's going to give me some information about this particular 3D model, right? So like it's telling me the level is ball, number of vertices, number of indices, and the scalar values that I have defined on top of the mesh, etc. Right? So that's one thing that you're going to see, like any artifact that we produce via drawing or, you know, like via the CAD cell or AI cell, whatever, they are actually referenceable from the code cell directly in the notebook, basically, right? So whatever level we put for them, we are able to reference it. Okay, so, and then like we just wrote code for the heat equation over here, solving the heat equation, basically, right? And this is generic heat equation solver on a mesh, basically. And then when we are, and I actually already ran this, right? Like I ran this, and when I said visualize time series, this is what shows up. And I think I probably have to restart this where I'm not able to get to the time series thing. Oh, I had like a nice animation bar that I could show, but so sorry that it's breaking. Like we're making changes every day. So, but there is animation bar that would show up, and like you could see over time how the like how the heat progresses on this model, essentially, right? So all of these we are doing. Like if you think about the actual pipeline that mechanical engineer would use for this, they would actually model it on Blender. They would take it to COMSOL or like some other simulation software. They would run the simulation over there, and then load the data on Jupyter Notebook and analyze it over here, basically, right? And this is what I mean by, can we have one particular workflow where or one one interface where all of these things are happening, and the different cells are referable, right? So I mean, I'm able to refer to a 3D model from my code cell. Yes, Razin, go ahead. Did you have your hand up?
Yes, yeah, I think that the outputs you're seeing, that was the result of a previous run. So I don't think that you actually ran the code. I think it will work when you run itself manually. Yes.
Okay. Yeah. Okay. Sounds good. Oh yeah, it is. It is actually running. Okay. Yeah.
Okay, so now you can see the time series.
Yeah. Okay. Yeah. So I can actually show you that. Thank you for that, Razin. So Razin has been working with me too on this on the project. So yeah. So as we move forward, like you see the heat simulation, like heat dissipating. So I defined these areas via the lasso, and now I see how heat dissipates over these areas. Okay. So that's the CAD cell, and I want to be mindful of the time. I want to open it up for some questions, and I also have some questions for the folks, basically, right? So that's one example. I want to quickly show the drawing example where we can draw different strokes and label them within Visual Studio Code. And then I can ask the AI, which I can't show right now because of the rate limit, but then I can ask what's the bounding box or center out of the curve, basically, right? And what it's doing underneath is the agentic infrastructure that I have shown, and I've kind of talked about this over here. This is sort of the architecture. You can read the paper. It's a work in progress paper, but I invite you to read it and give me any feedback that you might have. But what this is doing is it's utilizing the agent infrastructure to call tools, basically, right? And then in this case, we're not doing an extended tool call. We have a set of mathematical functions that we have already written as tools and created some agents that can deal with mathematical questions, basically, right? So yeah, so when I'm asking that, it's actually getting back to me with bounding box and centroid values, basically. So it is not the LLM doing the calculation, rather it's the tool call that's doing the calculation. So it's the agent is choosing to invoke some tools that we have already written in this case. This is also one example where we are doing like a solar, a planetary system simulation or animation, right? We can draw it, we can write the code, and you'll see that as I labeled them, like Sun, Mercury, Venus, Earth, and Mars, these particular strokes, I'm able to directly refer to them in the code, right? So sun.set color, for example. So and then we can just write code to manipulate. So not quite logo-like language, but it has logo influences in certain ways. So yeah, I will stop there. Going back to the presentation, I just want to point out some of the questions and challenges, but wanna see if there are questions from the audience at this point. Okay, so I will pose some questions and challenges as I'm building this and I'm kind of filling it to my bone. What are the main challenges? I would say, as I said, like I think the way we write our papers, like we are going by handcrafted schemas, and we are defining the mapping between the different layers of abstractions. And so how do we automate that in certain ways, right? Like, is it even automatable? That particular process that us as researchers we do, is that even automatable? And if it is, then can we define a visual grammar agent to do this for us, right? Like that would be one question, but I'm curious to hear if people have thoughts.
Hey, Saquib, my name is Benji.
Hi, Benji.
I guess the thing that I'm struck by is that natural language is this gigantic lexicon with ambiguous definitions. And once we get to a grammar of like iconic abstractions, we're narrowing the lexicon. And that, like, the interplay of that, like, how does the user and the tool like settle that? Because the tool is going to make some assumptions that are likely different than the user. And is there like maybe if there's some sort of reconciliation step, then from there, then there's this kind of better alignment, and so the tool becomes more useful. I don't know. That's the big thing that strikes me whenever we're trying to go from the non-deterministic to the deterministic, which we do in life every day, right? Like.
And I think some of the coding agents that we see, Anthropic or OpenDev put out like a long paper. I really enjoyed reading that paper, learning about their architecture. And I think what they do they're not exactly doing what you said. Like, I think that is still the challenge, but they iterate between a set of agents, basically, right? So like, over here we have, like, as we are generating code for Blender via the agents, we have like a thinker, writer, and reviewer agent, right? So you would generally kind of do multiple loops, like with Blender, that you produce. So what we have been building is you produce a Blender scene by generating code for that Blender scene. But then you feed it back to the thinker. But then, of course, LLMs have token limits, so you can't really give it, like, let's say, geometry information, right? And it's not going to do well with geometry information. It's not trained for that. And arguably, LLMs don't have, embodied intelligence. Not arguably, they don't, basically, right? It's a lookup table at the end of the day. So they don't have embodied intelligence, so they're not able to understand the scene. So we are dealing with that already, where we are defining the scene even in text, basically, right? Like, trying to generate description for that scene, putting it back to the thinker, and then, putting it back again, like, and trying to do a loop. That's our current, like, looping mechanism, and like do multiple loops and see what we get out of it, basically, right? In simple use cases, we have found success, but whenever we're going to some, let's say, complex structure, like even like if I take the mechanical engineering example, and like you're designing a plane, you can't really ask the agent, hey, design a plane for me and I'm done, right? Like, you have to be very specific, and even if you're specific, it may not remember all the constraints, like the geometric constraints, and it cannot understand geometry to begin with. Like, it doesn't have that intelligence, basically, right? So we are grappling with some of that, and then so probably our use cases are limited to simple things right now. But I'm curious, like, if you guys have, like, other thoughts or solutions in this case. I think the other thing that I would point out is what you said, Benji, is the very non-deterministic nature of language. Like even if you're writing skills, right? Like let's say for different fields, it will probably, not even probably, like we are already seeing that skills alone are not enough in this case, right? Like you can say that, hey, like maybe I'm defining, hey, don't output any garbage, or like I'm stick to this particular text, or like stick to these particular notations. We are defining rules like that, and you can get some basic level of work done in this thing, basically, right? But then whenever you're trying to make it a useful tool for an expert, they're going to say, okay, yeah, it's useful for my first layer of thinking, but then beyond that, it's not useful to me. So yeah, those are active research questions, I would say. Like anyone who's thinking about writing papers, like I mean, you can, like I mean, I feel like these are concrete problems, and we can go again. Like I think kind of I talked against handcrafted rules and all that, but then maybe the way is to actually define a large repository of handcrafted skills, basically, right? And that is the main work that needs to be done. I think there was like one question. So yeah. I mean, do you want to just say it? Yeah, I think it's probably easier.
Hello, can you hear me?
Yes, I can hear you.
Sorry, I just was like taking notes in the chat while y'all were talking so that I would but I'm happy to say the question out loud. Yeah, I feel like I've been talking to some designers, like UI designers, about how we've been using like Mockdown and ASCII to try and represent certain like design things to a language model more precisely, which I found just like interesting at a higher level, because it's like choosing a kind of language representation that makes it easier to convey what you want to a language model. And I wonder if you find yourself thinking, and other people in other domains also talking about this idea of like developing more domain specific languages, but like maybe something more between natural language and a domain specific language. There was also Matthew Badon-Lafon's work that he shared at Kai with like Belly Door that I'd been talking to him about for a while, about like analogies and trying to take like metaphors between UIs. But yeah, I've mostly been thinking about this in like UI design. I wonder if in like the space of trying to convey concepts about geometry and math to a language model to effectively do what you want, like there's any like intermediate representations or like domain specific terms that like are effective, or that you can see being more effective in the future. Like, so now I'm like wondering if people are trying to describe geometry with ASCII or something, if that's or if there's some other intermediate ways of bridging language and what will effectively get a language model to understand what you're describing.
Yeah, and certainly I think that can be one play. It's we're so early in this agentic exploration stuff, basically, right? Like I think all sorts of explorations need to happen, and I would be curious to see if there is a DSL that is more natural language. Like in other words, like we're still giving input in natural language, but we're aware of the keywords and how we say things, and maybe that is the way to go. And I also feel that the skills, again, like I feel like some simple use cases, the skill files are great, but I don't think, when it comes to very complicated geometric structure or something like that, you need to be able to define constants. That's why math exists. Math is a language, right? Like math is our shorthand to define these constraints, right? So and what we're probably saying is that, oh, like what is like, and you're also saying that, like what is the intermediate language between the symbolic math that we do and natural language that we have.
Yeah, and then this is less of a question but more of a it's just the thing I've been thinking about as well. Is I feel like people, a conversation I got into recently that I thought was interesting was about if this could make more research easy to like publish in a replicable way, where like already like with like math proofs, like because we have like the language of math, we can like essentially like describe work in a way that other people can replicate and like more precisely understand. And so I find myself wondering, like, also for other humans, if we come up with more ways of describing things precisely, that's in between natural language and domain specific language, we might like be able to like convey I don't know, different ideas more effectively in papers. And then like maybe I've been thinking about this in the UI design way, where like if there were a way to like have something like a proof written up about how you design something that you can publish in a paper, and then somebody else can give that to their language model and then like get the same thing built out of it. This is just a thing I'm thinking about, and less of a question, but yeah.
No, yeah, totally. And I think consistency, verification, accuracy, like these are another challenge with AI agents, right? And I've been building in the enterprise AI space for some time, right? Like, and well, it is hard to, you know, like sell an AI agent solution to, let's say, customers when they're like, oh, every output will be different. You ask the same question and like the outputs are different. So how do you constrain the outputs? How do you introduce other sorts of external constraints, external to the LLM, right? So the, and then not just skill files, like other sorts of tooling, others like, for example, in spreadsheet modeling, you could already have a particular spreadsheet model already created, right? And have the LLM reason from there. And if it's reasoning beyond some of the rows or columns or trying to do something funky, you say that, no, you stick to these particular rows and columns for your modeling, like anything that you're generating, right? So there are custom ways that we are seeing that are emerging in the like industry AI space, right? And I wonder if there is any equivalent here for math, science, and engineering.
Cool. Well, thank you. I'm very excited for all this work that folks are doing and the directions it could go.
Yeah, thank you. Yeah, that's a great question that you posed. So we are coming up on time, Sangho, but I think we also probably covered some of these questions too. But I feel like I keep coming back to this particular question. Like, if I were to leave people with anything, like I would say, how do we automate ourselves, really, right? Like, I mean, I think we as HCI researchers, we are at that certain layer where we are studying a particular domain. We are that DSL in certain ways, right? Like, and we are coming up with the maps. We are, as in the mapping, we are coming up with the elements, interactions, actions, and all of that, right? After studying a particular domain. And I've been kind of thinking, really, whenever we are trying to use generative agents for some of this work, we are asking, oh, how do we automate ourselves? And maybe the answer is we don't automate ourselves, but maybe something like, you know, like what you said, which is we have maybe a DSL or some intermediate language, or we have to rethink LLMs from ground up, where we are able to put in these mathematical constraints, like in the training data, right? So there are multiple ways to probably attack this problem, but it's all exciting, and it's all developing in real time as we speak. So yeah.
Yeah. Oh, yeah. I know we're ending, but yeah, I also wanted to just maybe leave a comment on that question too, because I was also thinking as I was listening. One thought maybe I will add is like also connecting Rabaya's sort of comment on, like, you know, which type of users you might be targeting, and right, that discussion of experts versus novices. Because I was also thinking about, right, like this going beyond handcrafted schemas and mapping between abstractions question, and right, I feel like maybe experts, right, they and what your comment just now about like how can we sort of extract our domain knowledge and right embed it to the agent, and I feel like maybe for experts, like it's easier for us to sort of like prescribe sort of our like constraints and like sort of the style that we want. But maybe for novices, right, it's usually you just want to focus on the familiar sort of constructs and like style, and give them the right, let's say, design or sort of I don't know, like grammar for them to work with, right? Because yeah, they are not expert enough to be able to also maybe they don't have engaged in these like workflows where they need to come up with their own sort of like mapping and abstraction. So that was some thought that I had. But yeah, I also wanted to ask a question about like how you were thinking about extracting those like domain knowledge, but maybe we give it the time. I don't know, unless you have something you want to say to that, or we can take it to the discussion.
I mean, I'll quickly, like maybe like a 20-second answer to that is, I am taking the old HCI approach where I'm going and chatting with researchers, right? And having them contribute to the project, so domain experts, not researchers, I'm sorry. So domain experts, but I do think it's almost like we have the domain experts build the skill files, test it out, and then we have a repository, basically, right? That is the like a very brute force method that I'm going by. I don't know if there is any intelligent or other smarter ways of doing this, but yeah.
Yeah, I think I was thinking about two things. Like one, I saw like on social media, someone like trying to create like designs, like how now people are working on like design skills file, right? And then I saw this one initiative by someone who's trying to like have like a collection of like, I don't know, like 200 design examples or something. And another thought I had was like for some sort of domains where like we have a bunch of textbooks, right? Where maybe that can be a source of some knowledge, but yeah, that was.
I think textbooks are great, but I think experts have that. I feel like textbook and expert mental models are like two different things, basically, right? So experts bring the taste and how they want a workflow to look like. And even beyond that, the textbook knowledge is very different from, let's say, an expert thinking through a problem. I think if you were to just write down the thought process of an expert, that would look very different from a textbook, basically, right? So, but I do think textbooks are interesting data points over here. But these are, again, questions that we need to figure out. But yeah, thank you. So
yeah, so we're on time. So let's thanks Saquib for a great discussion and the presentation. Thank you, Saquib, so much for I know he's been very busy because I know how he's been traveling, but yeah, thank you so much, Saquib. And